Introduction to several common line codes. Hello everyone, in this lesson, we will learn about several common line codes and their application scenarios. Commonly used transmission line codes include the following, and we will introduce them one by one. AMI code, also known as alternate mark inversion code. The encoding rule is alternately transform the ones marks in the message code into +1 and -1 while the zero spaces remain unchanged. As shown in the example below, example in the middle, its advantages are as mentioned earlier. No DC component, low frequency components, 3 level, with 0, +1, -1 levels, simple encoding decoding circuitry, and macro self-checking capability. However, transmitting long sequences of zeros makes timing recovery difficult. It is mainly used in PCM24 channel primary group, North American series as the line code at 1.544 megabit per second. HDB3 code is an improved version of the AMI code. The improvement aims to retain the advantages of AMI while overcoming its drawbacks, ensuring that the number of consecutive zeros does not exceed 3. 1. Check the number of zeros in the message code. When the number of consecutive zeros is less than or equal to 3, the HDB3 code is the same as AMI, with +1 and -1 alternating. 2. When the number of consecutive zeros exceeds 3, each group of 4 consecutive zeros is treated as a small segment, defined as BOOV, called a violation group, where V is the violation pulse and B is the balancing pulse. 3V has the same polarity as the immediately preceding non-zero pulse. This violates the rule of alternating polarity. Hence, V is called the violation pulse, and adjacent V pulses must have alternating polarities. V can be +1 or -1. 4B can be 0, +1, or -1, chosen so that V simultaneously satisfies both requirements in 3. 5. The polarities of marks following a V pulse must also alternate.
So confusing. There are so many rules. Could you give an example?
Sure. Assume the message code is as shown in the figure. We are already familiar with its AMI code. We check the parse with more than 4 consecutive zeros. For the first group, we add a violation pulse, -V, so that the consecutive zeros don't exceed 3. This -V has the same polarity as the preceding non-zero pulse, which is -1. If we continue adding pulses, according to this rule, after finishing, we find there is a -V, followed by 3 consecutive plus Vs, which violates rule 3 mentioned earlier. The polarities of V pulses must alternate. Then the balancing pulse B comes into play. Change the second positive V to -V, and simultaneously change 0 after the preceding positive V to -B, aiming to maintain the principle that the V pulse has the same polarity as the preceding one, and so on. The figure below shows the waveform of the HDB3 code.
This topic is quite difficult. I need to digest it properly after class.
Yes, please find similar case studies to analyze after class. The HDB3 code is used as the line interface code for a law PCM below the 4th order group. Although the encoding of the HDB3 code is relatively complex, its decoding is simpler. From the encoding rules above, it can be seen that each violation pulse V always has the same polarity as the preceding non-zero pulse, including B. This means that from the received symbol sequence, the violation point V can be easily identified, and then it can be concluded that the V symbol and the three symbols preceding it must be consecutive zeros, thus restoring the 4 consecutive zeros. Then, by changing all -1s and +1s into 1s, the original message code is obtained. The following exercise is left for everyone to practice after class. Hello everyone. Today we continue to introduce line codes for baseband transmission. Manchester code, also known as biphase code. The encoding rule is 0 is represented by 01 and 1 is represented by 10 characteristics, 2 level opposite polarities. Thus no DC component, rich in bit timing information, simple encoding decoding circuitry, consecutive identical bits, do not exceed 2. The drawback is that the bandwidth is doubled compared to the original signal because the symbol duration after encoding becomes half of the original Manchester code is a transmission line code used in local area networks, length CMI code, also known as coded mark inversion code. In older telegraphic codes, 1 is called a mark, 0 is called a space. Coded mark inversion means representing 1 with alternating 1 1 and 0 0, and 0 is fixedly encoded as 0 1. Characteristics: bipolar 2, level encoding, consecutive identical bits, do not exceed 3, used as an interface code for a low PCM fourth order group, used in optical cable transmission systems with rates below 8.448 megabit per second. MBMB code. The encoding rule is as follows. We want to transmit M bits of information code, but we convert it into M code symbols for transmission. M is greater than N. Since M is greater than N, the number of combinations for M-bit symbols is greater than for N-bit combinations. So we select the 2 to the power of N allowed code groups from the 2 to the power of M combinations, and the rest are forbidden code groups. In the example below, what are the forbidden code groups? The answer is 10 and 01 are the forbidden code groups. The characteristic of this encoding is it can provide good synchronization and error detection functions. Subsequent channel coding can adopt this method for error detection. Of course, the required transmission bandwidth increases with M. Commonly, M equals N plus 1 is chosen, such as 1B2B, 2B3B, etc. NBMT code. For example, 4B3T code, which transforms 4 binary digits into 3 ternary symbols, an improvement over the 1B1T code. Its characteristic is at the same symbol rate. The information capacity of the 4B3T code is greater than that of 1B1T, thus improving spectrum utilization. 4B3T code, 8B6T code, etc. are suitable for high-speed data transmission systems, such as high-order group coaxial cable transmission systems. If you want to transmit the same number of information bits and wish to save bandwidth, which transmission method should you use? What if you also want error detection capability? Can you analyze NBMB and NBMT? I hope everyone will think about the above questions after class, and even better, provide me with feedback on the results. That concludes our study of line codes for baseband signals. Thank you.